Hello everyone, welcome to this session on electromagnetic fields. We are discussing examples on electric field intensity, where we are continuing our previous examples. So let us begin with our first example of the day. Today we are discussing examples on various charge distributions. So in this series, first one we are considering an infinite long uniform line charge. So basically what is a line charge? Basically a line charge is considered as distribution of charges over a line. So here if we draw one line like this is nothing but a line. Line means there is a current carrying conductor or any place where charges are flowing. So this line, if we have to choose its shape and its coordinate system, if you observe this line, if you zoom out, its shape will look like a cylinder. So it will look like something like this. So this will be the line charge, the line distributed, and on this line charge, these charges may be applying some force on the surrounding region. And that force per charge is defined as electric field intensity. So here we have to consider one infinite long line. That means this line is extending to infinity, right? So this is about line charge. On line charge we consider rho L as the line charge distribution. Okay, so here what the given data is, we have rho L. Rho L is given, the value of charge density is 3.0 nano coulomb. So this is the value of rho L. So we'll note down the given data. So we have given with rho L for this complete line. So rho L is equal to, what is rho L value? 3 nano coulomb. That means 3 into 10 to the power 9 coulomb per meter. And the location of this line is given. In that there is x, so not given, so we have 3, 5. So this is z and this is y. So what we have to find out? We have to find out electric field intensity first at origin, then some point where y and z is given, and then third point where some other points are given, x, y, z, all three components are present. So first let us consider some general point, say x, y and z, and then the radial vector from the location of rho L, that is say x, 3, 5 to x, y, z. So what we have to find out? First we have to find out the r bar. How we find out r bar? Destination points minus source points. So what are the source and destination points in this case? First case, if we consider, we have say y minus 3, x is not given and another point is 0, so it will cancel. So this is ay cap plus z minus 5 az cap. This is the r, and what will be the mod of r bar? Mod of r bar will be square root of these terms. So say one is y minus 3 whole square plus z minus 5 whole square. So total AR cap. What is AR cap? AR cap is equal to R bar divided by mod of R bar. So this division is nothing but AR cap. Okay, so let us put it at one place. So we will take its division this whole term we have to divide. Okay, so this is our numerator, this will be our denominator. We have to put this. Now what is the formula for electric field intensity? Electric field intensity at some point, say x, y and z. What is formula for infinite line charge? Infinite line charge formula is rho L divided by 2 pi epsilon naught r into AR cap. So in place of AR cap, we have to keep this value. Rho L is given, and we also calculated 1 upon 2 pi epsilon naught. So this 1 upon 2 pi epsilon naught value is 18 into 10 to the power 9. So let us calculate E bar. So E bar will be equal to, we'll keep the values. Rho L is, say, 3 into 10 to the power minus 9 into 1 upon 2 pi epsilon naught is 18 into 10 to the power 9. Then y minus 3 AY cap plus z minus 5 AZ cap divided by y minus 3 whole square plus z minus 5 whole square. So this is first expression, a general expression for x, y, z. Now same expression, what we have to do, we will consider the cases given in example. The first case is, we have to find out electric field intensity at 0, 0, 0. That means we have to calculate electric field intensity at origin, where coordinates are 0, 0, 0. So let us directly keep the values. We can calculate this one. It will be same for all. So what we will get, say, we will have E bar. We have to calculate E bar at origin first. Say E bar at 0, 0, 0. So first let us calculate this one. So let us put the values. We will get 54 minus 3 AY cap minus 5 AZ cap divided by 9 plus 25. So if we solve this value, we will get E bar is equal to, say, minus 3.17 AY cap minus 12.7 AZ cap volts per meter. This is electric field intensity. Then second point, we have to calculate electric field intensity at 0, 2, 1. So let us calculate for second. E bar at which coordinate? 0, 2, 1. So let us calculate for this. The same constant, say 54, and for new points, destination and source, will get 2 minus 3 AY cap plus 1 minus 5 AZ cap divided by 1 plus 16 volts per meter. So you should practice this on calculator. So I will write the answer here so you can tally. So minus 3.17 ay cap minus 12.7 az cap volts per meter. So this is the E bar for this term. Now what is the third one? Third point we have to calculate for point 3, 2, 1. So here we will calculate the third one. Third one, E bar at 2, 3, 1. So let us put the values here. So here we will put the values, say 54. This will be minus 4 az cap divided by 16. So if we solve this, we will get minus 13.5 az cap, and the unit is volts per meter. So this is the solution of this example. Let us move to next example. Now next example is, we have infinite sheet. Now here we are starting the problems on surface charge distribution. So surface charge distribution means there is one infinite sheet on xy plane extending from minus infinity to plus infinity in both directions, has a uniform charge density of 10 picocoulomb per meter square. Find the electric field intensity at some height z equal to 1.0 centimeter. Now for understanding this, we have to remember the setup of this equation. So now suppose this is a coordinate system. Fine. Now what is the xy plane? Xy plane means, say this is our, I will write on the coordinates here. Say this is, for example, this one is z. This is z. So this is y. This is x. And this is z, y, x. XY plane means this floor. This one. So here we have to consider one infinite sheet on which surface charge density is present. That surface charge density is given as, say, rho s, and this value of rho s is given as 10 picocoulomb per meter square, and we have to find out its effect on z is equal to 1. Say this is z is equal to 1 centimeter. So how much this sheet, infinite sheet, is applying electric field intensity on this point, say Q. That is the question. So we have to find out it. So let us solve this. So we will first note down the given data. Given data is, here we have rho s is given. Then formula for surface charge density we have to remember. Now in place of rho l, we will have rho s. So it will be rho s by 2 epsilon naught a r cap. Now in this case, direction of electric field intensity is in z direction. So we can take az cap. So this is the formula. So already 1 upon 4 pi epsilon naught is 9 into 10 to the power 9. So we can calculate this constant 1 upon 2 epsilon naught. If we calculate this value, it will be 18 pi into 10 to the power 9. So this value we have to keep in electric field intensity. So in our formula, rho s is already given, that 2 into 10 to the power minus 12, that is pico coulomb, into 18 pi into 10 to the power 9. So electric field intensity will be equal to, if we calculate this value, we should get 36 pi Az cap millivolts per meter. So this is the answer for this question. Let us see next example. So now this is our example. A sheet of charge. Again the sheet of charge. This is a problem based on the surface charge density. So we have to consider, now we have to consider it on YZ plane. Again, to imagine that, we can consider a rectangular system here. What are the components here? Say this is y-axis, say this is x-axis, this is z-axis. YZ plane means this one, the front view of this classroom or this square box, you can imagine. So this is nothing but the YZ plane. Now due to this YZ plane, we have to find out on -5. What is -5? That means on x we have to go back side, on negative side. On negative side we have to find out the effect of the sheet which is present back side, right? So basically this sheet what we are considering is like this is the sheet rho s, and it is applying some electric field intensity backside, negative x. So say this is YZ plane, and there is some charge distribution rho s. This value is 5 pico coulombs, right? So this is 5 pico coulomb value given for this example. So next what we have to do, so next we will see we have to say put it in the formula. What is the formula? Formula for surface charge density. So the surface charge density related electric field intensity is E is equal to rho s by 2 epsilon naught Ax cap. Now Ax cap is in negative direction, so we can take minus here. So directly we can keep the values. We have given rho s as 5 into 10 to the power minus 12. This is again minus, divided by 2. What is value of epsilon naught? Epsilon naught is 8.854 into 10 to the power minus 12, and the direction is Ax cap. So if we solve this, we will get electric field intensity as, so final answer should be minus 0.282 Ax cap volts per meter. So let us see next example. Now we'll see one example with a setup. We have to consider a point charge. Point charge. A point charge Q is at the center of neutral spherical share. So say, let us have, this is our neutral spherical shape sphere. On this sphere at the center, we have to consider one charge Q on the surface charge density at inner surface and outer surface. So one will be, say, one surface will have A radius, second will have B radius. So if we consider the outer shell have positive charge, so as per the Gauss law, the inside sphere will have negative charge. So what we have to find out, the electric field intensity at the inner surface and outer surface. So already we have formula. So how we calculate? At surface charge density at, say, A, at radius A. So what it will be at A, we have minus charge, minus Q per area of this sphere is, say, 4 pi A square. So what is this? Cos per area, that is cos per area. And what is another outer sphere? So rho s at radius B. So outer sphere charge is positive Q, right? As inside we have negative Q. So now outside we have positive Q. What is rho s? Rho s is all the densities. How we remember them? All the density is equal to, say, cos or creator of that density by area. Now this is surface charge density. So who is this is volume charge density. If we consider sphere is the volume, so volume charge density is also having same relation. All the densities will have same relation, cos per area. So volume charge density or surface charge density or line charge density, they are created by charge itself. So it will be Q by some area A. If it is surface, then we have to consider surface in place of A. Now what is area of sphere? Area of sphere we take as 4 pi r square. Now for the outermost shell, r is nothing but B. So what will be the formula for this rho v? Rho v will be equal to plus Q by 4 pi B square. For which sphere? For the outer sphere. So this is the solution for this example. So with this example we will stop here. In next session we will see few more examples. Thank you. Have a good day.